Hello everybody, I'm Alexey Krabarov, the AI community architect at Neo4j. I'm also the founder and organizer of AI by the Bay. And here we are at the venue where we run it. It's going to happen in November. It's the Scottish Rite Centre in Auckland on the beautiful shores of Lake Merritt. So you can see me and my friend Vasilije on the Auckland Riviera here.
Hey
Welcome,
there.
Vasilije.
Nice to meet you. Thanks for the chance to participate today.
So Vasilije is the founder and CEO of FikaAI. Tell us what it does.
Yeah, Cogni is a memory for AI apps and AI agents. What we allow companies to do is to build an indexing semantic layer on top of graph and vector stores. We use Neo4j, we use many other graph and vector solutions, and we let developers easily use our SDK and build this semantic layer for them.
So, first of all, everybody talks about agents and frameworks, and I know you've been actually doing this for a long time in AI timescale.
Yeah.
So what brought you to this idea? And now you're basically, you've been one of the people who thought about it the longest. How did you come to this idea, and why did you call the company Cogni?
So yeah, back in 19th century in my country, no, I'm joking. Yeah, so back a couple of years ago, I was working in the big data field. I was building systems that scale, terabytes of data. And when I started getting involved in the AI, I saw that I really can't do this. I can't get anything to production. And what I could use, tooling like LangChain and similar, although they were very amazing for what they offered at the time, they really couldn't solve the problems of companies in prod. So I was building B2C apps. I failed, both because I don't know much about B2C, but also because I couldn't really scale anything. And then I decided to try and build this semantic layer on top of graph and vector stores and avoid all of these, let's say, assumptions about frameworks and assumptions that people do and overbuild, and just focus on memory, just focus on data modeling, data storage. And we want to be like DBT for LLMs effectively.
Mm-hmm. And you call it Cogni because you studied cognitive science.
Correct. So my background's in business, but then around 10 years ago, I switched to the big data field because Germany wasn't really giving, let's say, work visas for anything else than doctors and programmers, and I couldn't cure anyone, right? Mm-hmm. So I decided to pretty much sit down, learn how to code, build data systems, and then I went back into the social sciences, studied clinical psychology, and with all of this kind of, let's say, tools at my hand, I saw that when we are talking about LLMs, we are talking about these systems that kind of continuously evolve, continuously produce new data, continuously need to be updated, and that all this relational modeling and relational data approaches won't really fit in this new, let's say, framework we need to build for the future. So that's how I came up with the idea. And I started on Twitter. Things kind of escalated slowly. People liked what I posted. I posted snippets and ideas, and then I figured I'm onto something. Now it's called AI memory. We still don't fully know what it is, but I think over the next year or two, we'll nail down a couple of really good use cases, and we already have a few ideas what those are.
You know what's really funny is it all became super clear to me also fairly recently because all these agentic frameworks popped up, and it's kind of a set of cookbook recipes for different people to call functions agents, right? And it's kind of renaming of things, but without explaining what they do differently. But it became very clear to me because Neo4j is doing a sequel to its deep learning AI course. So my colleague Andreas, the ABK of Neo4j, is doing it. And so he decided not to do any frameworks. He just decided to use Neo4j as a knowledge graph, as the agentic memory. And so that, I think, makes it super clear because agents go somewhere, do stuff, and then store it in the graph, and other agents can see that. And so that made very clear to me that, first of all, it can also be parallelizable because one agent can work on one part of the graph, the other agent can work on the other part of the graph. And so it becomes obvious if you do all these agents, then you need to store the results and the state somewhere, right? But so first of all, you started doing this for a while ago, and you said performance was not enough. What made you think that memory is the thing that will scale performance?
Yeah, so effectively what you mentioned, and that's, I think, good thing about the agents. I think agents are an overcomplication of a simple call to a transformer, right? So we do a call to a transformer, and that doesn't call any state, and we do n calls, and then we call that agents, although it's usually just a process workflow optimization. So let's kind of just say we're doing some independent calls that we can't hold the state of, and then effectively, as we do many of those, because we need to get to certain results and we pretty much brute force it. Kind of storing the state efficiently becomes a problem as you are increasing the number of these calls and as you are making more and more complex sequence of chains of these calls. So memory in this context, especially graphs, can help with, as you mentioned, isolating the certain areas where we need to focus more, but also by actually allowing us to create these types of associative layers and like more complex layers that can reason in themselves on top of, let's say, the relatively static data that we already preloaded to our system. So this would enable both less calls on this agentic framework side, but also less, let's say, drain on the agents themselves, where they need to carry more data than they actually need to at this point in time. So, the context windows become shorter, they become more efficient, and then the data storage is acting as a pretty much intermediary buffer for us to use. So how humans usually operate there is like, they have this short-term memory. We hold up to 7 things at one point in short-term memory. We don't hold 75,000 things. And currently what we do with agents is we're trying to get them to remember everything over like a million context windows, and that's unnecessary. So that's why we kind of need this AI memory to store the data, so we retrieve what we need when we need it, versus just kind of doing this inefficiently as we do now.
Interesting. And so I'm very curious, so you studied cognitive science. So I had a brief interaction with cognitive science when I was at Penn, so this Institute of Research in Cognitive Science, and in kind of late 90s, early 2000s, cognitive science was this very interesting kind of cult of brain research. They would go to the whiteboard and they would draw block diagrams how they suppose cognition works, and they would have memory on some other stuff, and they would basically proclaim like, this is what I believe how things work. And like, it totally looks like what people are doing now with agents, right? They basically go and draw block diagrams what agents should do, and they basically say like, agents is a thing which can plan, and then it plans, and then it makes decisions, and like everybody and their mother and brother and uncle have like this block diagram. And especially it's interesting if it's done by like folks in their 20s who did not go to study cognitive science, or right. And so like, to me it sounds like a cargo cult. We kind of theorize how cognition works without making any experiments or any empirical evidence, right? Like, that's what I built. So a lot of this agent frameworks is kind of, here's my recipe, and it's no better than anybody else's recipe. And first of all, you went to school to study people who actually try to figure out how it's done in the brain. I mean, it doesn't have to be like in the brain, maybe it's different. But what do you think of all of that? Can we ground this in reality somehow, or optimize it, like you say, for like shorter context and more efficient retrieval? How should we rigorously formalize the question what agents framework are, right? Like,
yeah, that's a great question. I think we don't need to formalize what agent frameworks are. We need to evaluate them. We need to evaluate the accuracy of them. And what we did on our end is to effectively set up an evaluation framework that when we run Cogni and when we create the memory, every delta that we do in the system, we can measure the benchmark, the performance, and the changes. And then we know if we're actually doing something or is it just wish-washy. And I think if we can actually extrapolate that to the agentic frameworks and first to the memory space and then to the agentic frameworks, we would have much better understanding of what happens. What I'm seeing now is that most of the systems and most of the people are rushing so fast to production to kind of do solve these business use cases to a degree that they can, that they don't really measure or benchmark anything. So what I know in cognitive sciences, and I have a friend here at Berkeley that actually does the research on that side, and he's trying to model like the risk in humans and how do they actually take the risk in certain ages. What they do is like they set up these models and then they validate them both with the subjects, the humans, but then also he builds RNNs that replicate back his models to him, from the other side. So there is like two-sided validation that happens at any given point. And I think like what we need to do here is we need to both validate that with the end users that want to use the tool and are happy with it, but then also we need to have like more rigorous benchmarking evaluation frameworks that need to be plugged in at every step of the way, so we can really see if this assumption set is changing anything or not. Because as you say, there is a lot of ideas, and I think human cognition is just one inspiration point. I think we're gonna go past that in a couple of years, and it's gonna evolve into something of its own, but it's a better starting point than I sat with my friends and thought of a new idea which probably already exists if you did a bit of research and you saw how to implement it.
Right. And I think you said that Cogni integrates with a whole bunch of various systems. So can you like mention them and like what would be the criteria? Why would you choose, for instance, one or the other if you have freedom, or is it kind of you integrate with everything because people use everything for kind of agent frameworks?
Yeah, so most of the agent frameworks right now are relatively unstructured and they have their own way of doing things, as you mentioned. So what we do is we enable ingestion from any of 30, let's say, different systems, so relational databases, APIs, whatever is out there, and we do that in a structured way. In terms of like the chunkers and like the way you want to structure your data and process it, we also enable using LangChain, Llama Index, whatever is there on the market. In terms of the destinations where we put the data in after we index it, we support Neo4j, Kuzu, the standard graph databases, but also standard vector stores like Pinecone, BV8, and others. And in terms of LLMs, also Ollama, too, everything you want to use on your own. And very interesting thing is people are starting to play on their own local machines with Cogni, and we hope to see that evolve, especially towards a mobile SDK in the future. So for us, we try to build a modular system that we can effectively just do the memory indexing and based on cognitive sciences, but also based on graph science and based on big and good computer science principles, so we can scale this. And then on top of that, we are happy to see where others evolve and where they kind of bring the innovation in, and we are happy to use whatever works for them.
Very cool. And I think you have a kind of rapidly evolving roadmap. Can you tell us what's currently your next milestones? And I know you have design partners and customers. Like, what's the state of the universe in your world?
Sure. So we just finished the scalability piece, so we can now deploy on modal with hundreds and hundreds of containers and process up to 1 terabyte of data. That's enough for most of the use cases we've seen. And in terms of actual practical use cases, we are working with a construction company in Singapore to map all of the supply chain issues and create semantic layer for LLMs to use there. We are also working with an educational institution here in the US to help them provide better, let's say, assistance for teachers when they're working with impaired children. So we have another set of 3-4 use cases that are kind of popping up, and we're probably going to be publishing more about them in the coming weeks. We're also internally working on a couple of things connected to cognitive sciences, so summarization, associative memory, connectiveness within the graph and within the vector store. We are working on embedding the graphs into the vector stores. So a lot of innovation on our end, and we hope to kind of publish most of that into the open source. We have a paper on archive coming out in 2 weeks, and we're going to be showing a poster on the Prague ML conference on Monday. So I'm flying right away over there, and that is going to probably set the stage for what we will call, let's say, this cognitive framework that we want to publish in the next couple of months as the innovation standpoint.
Very cool. I'm very excited because kind of you're connecting this cognitive science and deep questions of cognition and semantic layers for LLM. I think it's a perfect phrase, like what we should aspire to. And plus, you're popularizing everywhere. It's like you're here third time, I think, in the recent months,
yes.
Right? And then you're going to batch of events. So if you're attending these events, connect to Vasilije. He's super fun to talk to about this stuff, and check out Cogni.
Yeah, I would be happy to hear your thoughts, and happy to exchange about new theories and approaches. We are always happy to hear your stuff.
Fantastic. Thank you, guys. See you around. Thanks, sir.
Thank you, sir.
That was fun.